I swear, I'll never use this in real life.
Oh, you poor clueless child. You use gas holes every day.
And we're here to prove it.
Who are you?
Rabbit boy, master of pressure and volume.
And I'm Jacques Charles, king of temperature and volume.
Okay, but how does this help me in real life?
Boyle's law states that the pressure exerted by a gas is inversely proportional to the volume it occupies, as long as the temperature stays consistent.
In a demonstration of Boyle's law, we'll place the balloon in a vacuum bell jar. We'll apply a vacuum, which basically pumps out the air in the bell jar. The pressure outside the balloon will be greater than the pressure inside. The balloon expands to try and equalize the pressure. Volume and pressure are inversely related to each other. When we release the vacuum, the pressure increases and the volume decreases. As another demonstration.
So you see, P1 equals P2 V2.
Okay, cool, but when would I ever use that? Why is my chip bag all puffed up?
Aha, because you took it on a plane. The air pressure outside is lower at high altitudes, so the volume of gas inside the bag increases, making it puff up.
Okay, that actually makes sense.
Charles' law states that the volume of a gas is directly proportional to its absolute temperature in Kelvin, provided that the pressure remains constant.
For Charles' law, I blew up a balloon, I placed it in boiling water, and when I did this, the volume increased, and then I placed it in the ice and the volume decreased. This is because Charles' law shows proportion to temperature.
So you see,
Watch this.
Huh?
I swear my basketball was fine just yesterday.
Why is it flat today?
did you leave it in the cold?
Yeah.
That's Charles' law. When the temperature drops, the volume of the air inside decreases, making your ball deflate.
Whoa! Science explains my life.
Did somebody say temperature and pressure?
Lawssssssss's law states that pressure and temperature are directly related. Basically, what this means is that the temperature in Kelvin increases or decreases. The pressure, which is measured in kilopascals, atmospheres, millimeters of mercury, or torr, increases or decreases as well. As the burning matches are dropped into the bottle and then covered with the egg, they're heating the gas inside the bottle, and so the pressure is also high. When they burn out, the air inside the bottle cools. As the temperature decreases, the pressure decreases too. Consequently, the air pressure on the egg from outside of the bottle becomes greater, forcing the egg to...
So you see,
Ever notice that in winter your tires lose pressure? That's because lower temperatures decrease volume and pressure.
When pressure, volume, and temperature all change,
The combined gas law formula is P1 V1 over T1 equals P2 V2 over T2.
Take an empty plate and fill it almost to the top with water. Then choose a color and add a drop or two of food coloring. Now take a tea candle and float it in the water. Then light the tea candle. Finally, take an empty glass and turn it upside down over top of the candle, and then watch what happens. The reason this happens is that the air coming off of the candle flame is over 1,000 degrees Celsius. And once the candle flame goes out, it starts to cool down, lowering the pressure inside the glass, thus allowing the higher pressure air in the room to push the water into the glass. If you were to put this plate in a vacuum chamber, the gas inside the cup would then have a higher pressure than the gas surrounding it, allowing it to push the water right back out again.
do you guys ever... Boom. Science. Dalton's law states the total pressure of gas mixture is... Dalton's law states that the total pressure of a gas mixture is the sum of all its particle pressures.
I have Dalton's law of partial pressure, and for this I'm going to use a little bit of symbolism, and I have three glasses of water, and each stands for its own gas. So for the blue it's hydrogen, the orange it's nitrogen, and the red it's oxygen, and each gas has its own partial pressure, so we're going to add the hydrogen in, and then add the nitrogen, and the oxygen. So you're adding each of the gases into the container, and together it's going to create one whole partial, or total pressure.
Dalton's law of partial pressure is equal. Gas laws are everywhere. My chip bags, my basketball, my car tires, even my ears.
Now you
Understand.
Gas laws.